Okay, so higher order derivatives. Now see, if you have a function f of x is equal to 3x raised to 4 minus x square, okay, and when you differentiate it first time, okay, that means when you differentiate it first time, so you find out what is f prime of x. So what will you get when you differentiate it first time?
So 12x cubed minus 2x.
12x cubed minus 2x. Now if you differentiate this function again, that means f double prime x. Can you differentiate this function again?
Then it would be 36x squared minus 2.
Yes, and again,
Um, then it would be 72x.
yes, and then 4 times,
Then it would just be 72.
just 72. Now these derivatives that you see after the first one, this one is called the second order derivatives. This one is called the third order derivative. This one is called the fourth order derivative. And these are your higher order derivatives. Okay, so these three, these are nothing but your higher order derivatives. Simple, right?
Yes.
So first derivative, second derivative, third, fourth, and fifth. Okay. Now, why do we even find out the higher order derivatives?
Um, I don't know.
Okay, so that will come under application of higher order derivatives. First, Anika, let's you try out this problem. You have to find out, so we have a function x square plus y raised to 4 is equal to 10. This function is implicitly defined. It is not explicitly defined, it is implicitly defined, and you have to find out the value of y double prime. That means the second order derivative of this function. Okay, so first let's differentiate it first time. So what will you get when you differentiate x square?
2 2x.
2x, okay. Then what do you get when you differentiate y raised to 4?
4y cubed.
4y cube. And also there will be the term of dy over dx.
Because it's y prime.
Yes. And you know,
Okay.
dy over dx can be also written as y prime. So these notations are exactly same. You should know this. Dy over dx is same as y prime. Okay, both of these notations mean that we are differentiating y with respect to x, and y double prime means d2y over dx square. It is read as d2y over dx square. So this means that we are differentiating y with respect to x two times. Okay, so instead of this dy over dx, I will write y prime, and derivative of 10 will be 0. Okay,
Okay.
okay, now we have to differentiate it again, because we
So then
hmm,
2
2
plus 12y squared times y prime
hmm, and
is equal. to what plus?
No, so see, this is now you will apply product rule here. This is product of two functions, right?
Mm-hmm.
Not y cube, y prime. By now it should come to your mind that since this is a product of two functions, so first we are first we are finding derivative of this function. Okay, now here you will get slightly confused. See what is happening here. You know this term, if you want to differentiate it, you do it side, like in your rough work. So you write it here, 4y cube times y prime. Okay, first you differentiate this function. What will be derivative of this function?
12y squared.
12y squared times derivative of y, right?
Yes.
And then you write the second function as it is, right? And plus, then you differentiate this function. What will be the derivative of this function?
Isn't
Derivative of y prime will be y double
y
prime.
double prime? Okay.
Yes, double prime
Plus 4y cubed
times
times
4y
5.
cube.
Okay.
Okay, so this is 12y square times y prime whole square plus y double prime times 4y cube equals to 0. Now Anika, from this step it would be really difficult to isolate y double prime. Can you isolate y double prime?
Um, well, I could first subtract y double prime times 4y cubed
Hmm.
and move it to one side and then divide the entire equation by y 4y cubed.
Okay, so you're saying that first you want to take these two terms on the other side.
Yes.
Okay, so y double prime times 4y cube is equal to 2, sorry, minus 2 minus 12y square times y prime square, and then we divide this by 4y cube. Okay, yes, this is also correct. Yeah, now you can also simplify this. You can factor out a 2.
Okay, so then it's negative 1
Hmm.
minus 3y squared times y prime squared over
Hmm.
2y cubed.
Yep. Okay, so this is the maximum simplification that we can do. Or this, we could have made it easier by first, I'm just removing this. When you have done till this step, okay, then after this, can you write y prime, like you just try to isolate y prime at this step, so you'll get negative 2x over 4y cube. Is that right?
Yes.
Okay, so now you differentiate, now take derivatives both the sides. Okay, so take its derivative and take its derivative. So derivative of y prime will be y double prime, and let's simplify this. This is negative x over 2y cube. Now it would be easier to find out the value of y double prime. You just have to differentiate this function. Okay, Anikas, let's differentiate this function. Negative x over 2y cube using the quotient rule.
So that becomes um so that would become first negative 1 times
Hmm.
2y cubed minus negative x times 6y squared over 2y cubed squared.
Okay, you're forgetting. See, whenever you're differentiating y with respect to x, the y prime term will also come. So this is correct. Negative 1 times 2y cube minus x times 6y square, which is the derivative of this. Then there will be a y prime term as well, right? Because it's y. You're differentiating y with respect to x. Whenever you are differentiating y term with respect to x, okay, so this is the function 2y cube. When you differentiate it with respect to x, so you get 6 y square, and there will be a y prime term as well, right? This is how we used to do implicit differentiation. Anika, tell me if this step is clear. See this, how did we get this y prime here?
Because
Hmm.
that's what we do
Hmm.
whenever like we're finding out like y in terms of x.
Exactly. So same thing we are doing here. There is y cube in the denominator. So we are differentiating this function with respect to x. So you did that right, 6y square. Derivative of 2y cube will be 6y square. And there will be a y prime term. You also not respect, you also differentiate y with respect to x. So don't forget this term. And then in the denominator we have 2y cube whole square. Okay, now we can simplify the terms. Negative 2y cube minus 6xy square y prime over what will be the square of 2y cube?
Right, so that's 2y to the power of 6
Hmm?
2y to the power of 6.
No. 2y cube whole square.
Oh, 4y.
4y to the power of 6. Okay.
And then do I divide everything by 2?
Yes, then we can simplify this.
So
What can
negative.
we factor out? We can factor out a 2, and you can also factor out y square from every term. Divide by 2 and also divide by y square. Here you have y raised to 3, here y square, here y raised to 6. So we can also divide by y square.
So negative y minus 6xy cubed.
negative y minus 3x.
So 3xy and then y cubed.
What happened to y prime? Y prime is there,
Oh,
and over 2y raised to 4.
yes,
Yes.
yes.
Okay. And that's it. That's your answer. So this is the value of y double prime.
Okay.
So Anika, do you have any school worksheet on higher order derivatives?
No, not for higher order derivatives.
Okay, and did you try out the questions of what was that? Implicit differentiation and uh, derivatives of inverse functions on IXL?
Uh, I haven't been able to. I've been really busy.
And did you get a chance to work on the worksheet, like uh, inverse functions, derivative of inverse functions?
I only did a couple of questions, not many.
Because that worksheet is really good. That's really important. Okay, so Anika, now let's see. Can you find out f3 of f3 4 if f of x is equal to square root of x? Now this means what, Anika? This is raised to 3. This means that we have to find out the third derivative of this function, and then whatever you get, whatever will be the third derivative, we will plug in x is equal to 4. Okay.
Okay.
Okay, so first let's find out the first derivative.
So 1 over 2 root x.
1 over 2 root x. Then the second derivative, so that means differentiate it again.
Would it be 1 over root x?
1 over root x. Now again you just write it in the notation, 1 over 2 times x raised to negative 1 half. Now try to differentiate this.
Oh wait, would it be 1 over 4 over root x?
No, no, no. You, what do you do? Power rule, apply the power rule. What was the power rule, Anika?
Um, the power rule?
How do you differentiate x raised to 5?
Well, it just becomes 5x to the power of 4.
So apply the same rule to this function and differentiate it.
wouldn't that be converted to root 2? I mean root x?
No, don't think about roots. Just tell me the exponents. What will be the exponents?
Negative 1/2 minus 1 is equal to negative 3 over 2.
And what will be the coefficient? This comes forward.
Mm-hmm.
This comes forward. And you already have a 1/2. So 1/2 times negative 1/2 times x raised to negative 3 over 2. Is that right?
Yes.
Yes, this is correct now. Now we have to differentiate it 3 times because we want to find out the third derivative. So differentiate it again. Now this is the exponent.
Times negative root 3 over 2.
Yes, you bring it in the front times negative 3 over 2 times x raised to and do minus 1.
Um, minus 5 over 2.
Minus 5 over 2, exactly. Okay, now let's simplify this. So multiply all these three coefficients. What will you get?
Negative 1 times.
Yes, Anika, what will be 1/2 times negative 1/2 times negative 3?
Would it be 3 over 8 root 8 x to the power of 5?
Yeah, you can just keep it like this if you want, and or 1 over root x raised to 5. Now you have to find out what is the value of the third derivative when x is equal to 4. This is when x is equal to 4. Okay, so just plug in x is equal to 4 in this answer. So f, third derivative of f when x is equal to 4. So plug in x is equal to 4. So 3 over 8 times this is 4 raised to negative 5 over 2. So now simplify this. 4 raised to negative 5 over 2. What will be that?
So 2 to the power.
Hmm.
So would it be 1 over 2 to the power of 5?
Mm-hmm. Exactly. 1 over 2 to the power of 5. 1 over 2 to the power of 5. And that will be what?
1 over 32.
1 over 32. And then finally this will be 3 over 256. That will be the final answer. Okay, Anika?
Okay.
Okay, now I will tell you some applications of higher order derivatives, which are nothing but word problems. Okay. Anika, you remember we did the interpretation of derivatives where we did some distance functions and we were finding its derivative to get the value of speed. You remember that? Yeah, these questions.
Yeah. Yes.
So we had a distance function, and when we differentiated the distance function we got the speed. When you have displacement function and when you differentiate it you get velocity. So this is f and this is f prime. And when you have velocity function you differentiate it, you get acceleration. You remember this?
Yes.
Okay, so I'll tell you one more thing right now. See, if you have a distance function, okay, and you differentiate it. So let's say that you have a distance function f of t, okay. When you differentiate it one time, you will get, sorry, this is not distance, but let's call it displacement. This is your displacement function. When you differentiate the displacement function, you get your velocity function, okay. And when you differentiate the velocity function, when you differentiate the velocity function, then you get your acceleration function, okay.
Okay.
So this just means that you can differentiate the distance function two times. So you first differentiate it one time, you'll get the velocity function, and if you differentiate it two times, then you will get acceleration function, okay.
Okay.
This is where we can use the application of higher order derivatives. So let me take a problem.